you everybody for coming, and thank you Elastic for the invite. Just from my understanding, because I just came to the room, to get an understanding of the audience, how many people are from an engineering background? Okay, roughly 20%. How many are machine learning engineers or data scientists? 1, 2. So those are usually the people I talk to. So I'm sorry if this doesn't relate, but I'll try to make it so that it's a broad enough presentation. I'm going to be talking about RAG to riches, building enterprise-grade AI systems with ZenML and Elasticsearch. I am the co-founder of ZenML. My name is Hamza. I'm based here in Munich. I've been a software engineer and used Elastic as well in a lot of my previous life, and I was very excited when the latest Gen AI craze sort of translated finally into vector search with these retrieval augmented use cases, which I'm going to be talking about today. Just before I begin, how many of you know what a RAG application is? Oh, less than I thought. So then I should start with what RAG is before we talk about RAG and enterprise, because these are two different things. RAG means retrieval augmented generation. If you are ever interacting with a RAG, like a chatbot, just like this, even if it's ChatGPT, if it's deployed on your enterprises, usually it's interacting with a large language model, like, of course, Claude or OpenAI, but it doesn't know maybe anything about your data, right? So the way that you get your data into that LLM, that large language model, is you take the query of the user. So for example, I asked this bot, how do I create a hello world pipeline with ZenML? I'm going to be talking about ZenML today as well, which is a framework to create MLOps pipelines. And it gives me an answer. The thing is that OpenAI doesn't know what ZenML is up to date. So the syntax it's put here is actually because before I sent the results to the large language model, I queried a vector search, a vector store, and asked for the 5 or 10 most relevant documents to do with Hello World pipelines from our documentation. And then I sent those documents as well as the query, as well as the prompt, into the large language model so that it can look through those documents and answer. So this is one way that you can take your documents, your data, and somehow put contextual, relevant information to the large language model without having to train it again, right? So it's very powerful. And if you look under the hood, that's exactly what's here. So you have a query. The query is, what is a ZenML Hello World pipeline? You embed the query with embedding. So you turn this sentence words into numbers and vectors. You fetch those vectors and you query against a vector store. This is where Elasticsearch comes into play. It's very, very powerful for that. Then you do something called reranking, usually. I will definitely get into that. And then you take those documents, you take the prompt, you give it to the large language model, you say, hey, these are the 5 documents, this is the query, give me the answer. Great, works. If you have a big enough context window, nowadays the large language models do, it works. So that's what RAG is. If you ever want to introduce that into your enterprises, please do so. But that was just a precursor. Doing this as a prototype is easy. Doing this in the enterprise is hard. And this is where tools such as Elastic and ZenML, to plug it, might be useful. What can it go wrong? So you might retrieve the wrong documents. It might retrieve, if I say a hello world document, it might retrieve something about NASA or like the Earth, which has nothing to do with the pipeline. Or it might retrieve a water pipeline, which has nothing to do with the ZenML pipeline, right? So it can just have the wrong context. It can hallucinate, it can be outputting the wrong format, it can be incomplete, hard to reproduce. Performance degrades at scale. Some enterprises here, I'm sure you guys have hundreds of millions of documents that need to get processed. Performance can degrade at scale. So yeah, there's a lot that can go wrong, to be honest. And it's even further complicated that I'm sure everybody is running on many disparate cloud services. So it can run on AWS, these things, maybe something is running on GCP, something is on Elastic Cloud. So there's a lot of tooling, especially from the machine learning world where I come from, which we have to put into this data world and somehow make it work. On top of all that, and this is the last challenge slide, I'll give you some solutions after this. There is a vendor lock-in risk. So if you just buy a platform, you're just going to go all in into a very nascent field. So the field isn't developed yet. Even people who are at the cutting edge are changing every month. Regulations are coming in the EU AI Act and all those things. What if happens if the chatbot says something racist, or if something, if there's sensitive data, there's also security involved. Elastic helps in that as well. Quality and reliability is something we talked about, but in the enterprise, you can imagine it's particularly important. And just how fast you are. Sometimes people forget that people who are actually implementing these things can be data engineers, can be software engineers, but probably they come from a data science background as well. And they want to be fast, and they work in experimental mode. So how can you make them fast and create a flywheel so that your RAG systems can improve? And that's basically the challenges that we're faced with as we go into enterprises with these RAG solutions. So what I'm here to talk about today is one possible solution, and the way to visualize such a system is, rather than thinking about it in terms of just an application that you need to deploy, you can think about it as a flywheel, a data engine. And if you start thinking about that, you might start thinking about pipelines. Pipelines meaning step one happens, that transforms the data, does something else, goes into another data point, and so on and so forth. So directed acyclic graph. And then once you start looking at it from a data-centric, a pipeline-centric point of view, you start seeing many pipelines emerging from this very relatively simple system. So you have embeddings. So embeddings are one of the most crucial things in RAG, because if you want to have nice retrieval, you need to have nice embeddings. It needs to know something about that. You need to index your data beforehand. You need to put it into something like Elasticsearch. There's something called reranking. A reranker is something I mentioned before, is something that takes retrieved documents and then gives them a rank similarity score from the query. And this can drastically improve your performance. So you have off-the-shelf re-rankers, but you might want to train your own re-ranker on your data. And then you, of course, have the large language model itself. You can use open source models, you can fine-tune them, or you can use closed source models, but yeah, maybe you need to interact with them as well. And maybe last but not least, there are way more pipelines around the system. Evaluation. It's very, very, very difficult to evaluate these things. So, I always used to make this comparison in MLOps, machine learning operationalization as well, that when we had normal software applications, in Python, for example, we had the requirements.txt file. We just had, the requirement. But once you have a data product, you can imagine every feature of your log is a requirements.txt file, right? It's like another requirement, and the data dependencies are very hard to analyze. Like, how do you tell, is your latest RAG system nice enough? Like, is that how can you quantify that? Like, is it concise enough? Is it toxic? Those things are very, very, very interesting, but hard to measure. So you need some sort of evaluation framework around that. Good. Nice. So RAG systems, I believe, are data pipelines at heart, because you need a repeatable process that runs these things over and over again as you iterate. And this is actually not new. So building a data engine, turns out, in machine learning is one of the key differentiators for most AI-first companies. You might see on the right, Karpathy used to be in Tesla, now in OpenAI, but used to be in OpenAI, now somewhere else. He said in 2022, and he's been saying it for a while, that the reason they beat other companies at Tesla was because they had this data loop figured out. So all the pipelines that got data from the car, got labeled again, fed back into it, which made their systems the best. And this data engine, a systematic, repeatable process with version control, built-in quality controls, automation, and feedback collection is very, very, very important to think about for especially people who are setting up in a system architect way these systems in the enterprise. I'm going to go through a few of these pipelines. just one by one, just to give you an idea of what sort of pipelines you can think of. And when you go back into your enterprises and talk to your engineers or are doing it yourself, you can also think about it from that framework. First pipeline is indexing, where you sort of, this is probably most familiar to everybody here, where you just take your data and you put it into something like Elastic. This is very, very powerful, and you can, there's one thing here which is very important in RAG, is you have to chunk properly. So just, you have to chunk the documents in a way that the retrieval is semantically correct. That's a whole science in its own. Metadata you need to put with it, so you can filter, handle multiple formats, and you need to configure your vector store if it's Elastic, for example, to make it a bit easier. The next is evaluation, as I said. So set up an evaluation pipeline that interrogates your RAG system by checking the right format. Like, is there any personally identified information there? Are there any qualitative gaps? There are tools and frameworks that help you do that, but you can also use simple Python to set those things up. But set that up from the very beginning. Reranking, if you're training a reranker, it really helps reduce hallucinations and out-of-domain generalization. I believe Elasticsearch supports that already. You can bring some rerankers custom, or you can do Cohere support, which is off the shelf. But regardless, it's very important that you have a pipeline that trains that as well. If you're doing a custom, which I believe it really helps. And it goes well with the hybrid search, dense and sparse index capabilities that Elasticsearch already has. And one of the most impactful things you can do just to improve performance is probably fine-tuning embeddings. So I saw Ash said that you can probably bring your custom embedding soon into Elastic. I think that's going to be quite cool, because if you fine-tune your embeddings on your data, it knows semantically more about your data, especially if you're in finance or something, which is very specific. And this can be a good step to give more understanding to your large language model to query the right things before you actually go and fine-tune the whole large language model, which is probably the most complex thing you can do. But once you do that fine-tuning, you can actually decrease cost a lot, because you can do model distillation. So you can take, for example, OpenAI costs and reduce them 10x if you just train a 7B model just on your data. So that's something I would suggest do at the very end. Before that, try to do the embeddings. And that's really a data-driven pipeline view of LLM ops for RAG, right? So you have all these pipelines. There are way more, by the way. I wrote that down at the bottom. But you can start seeing why this is complicated in enterprise, and how it can address some of the challenges that I said. But once you have that set up, the cool thing is you can just spin the data flywheel, start simple, and just spin it again and again and again, collect feedback, even if it's a thumbs up, thumbs down, annotate, put it back, repeat. And you can get a chatbot or whatever application that can really perform very well and give you a distinct advantage in your market. I have 5 minutes for the demo.
Sure, you have 10 minutes.
Oh, maybe I rushed that. I thought was that too fast?
No.
No, this was good. Okay, thanks. So I'm going to give you a technical demo, but to be honest, it's hard to run it because it's data pipelines, but I'm still going to try. For that, I need to tell you a bit about ZenML first. ZenML is a framework that helps tame this pipeline complexities. All these pipelines you saw, you can author them in ZenML. ZenML is a bit like, imagine it as Airflow or something for machine learning. It's particularly made for machine learning pipelines, integrates with the machine learning stack quite well. And this is how you write a pipeline. So it's just Python code. You decorate it with the step decorator, so you import it from ZenML. You put your code, which already probably exists, into it with a function, and then you configure a stack. That's the other big part. A stack is the configuration of your infrastructure. So let's say you're running on AWS for orchestration, or Elastic for vector store, or MLflow, or some other tools that might not be relevant here. You can just configure those, and ZenML then translates this code into the target infrastructure. So it can run on multiple different backends, and it does a lot of things for you that data scientists or ML engineers typically don't like to do directly, like building Docker images, interacting with Kubernetes concepts or something like that, deploying the models potentially, pulling data, stuff like that. We're going to start with a local pipeline, so let's do that. I'm going to take my cursor. You can see this is my basic pipeline. And actually, before I do that, let me give you the actual output. So this is ChatGPT. I asked it, write a simple hello world pipeline with ZenML. It was pretty good, but the thing is, it gave the wrong output. So it's saying from ZenML.pipelines import pipeline. This is wrong. This is older versions that it's trained on. And if I go to the bot that we have deployed, that's doing it correctly from ZenML import pipeline. So this is what RAG helps with. Like you can put your own latest data into your LLM with very relative cheap cost. And in order to get there, I had to write some pipelines. So the first pipeline I wrote was a very simple docs scripter. So I took my docs page, docs.zenml.io, scripted, loaded. I believe you can do this in Elastic natively, but there's some advantages of doing this in Python. You can
Is there a way to
make it bigger. That's better? Maybe one more. Should be fine. Right?
Thank you.
Yeah. So, and then you generate the index at the end after you generate the embeddings. And you can see the code is pretty simple, right? So you have, sentence transformer, for example. We don't need to get into the details, but let me call this pipeline. And while I'm calling it, I'm going to switch over to the ZenML dashboard. So in ZenML, it's open source, by the way, so you can try this for free. You have models and pipelines. When you're developing, what actually happens is a new version gets created, like 0.70 dev. This is the latest version of ZenML. This is the chat application is using this particular model version. So if I click into it, I see all the things associated with this version of my docs. So I have my embedding model, I have my artifacts. For example, I have things like visualizing the chunk size distribution. I can visualize things like, let's see what's here, personally identifiable information, toxicity. So there's lots of evaluation. In my evaluation pipeline, I've set up these test results. And I run this every time I run or make a pull request to GitHub. I can also see all my metadata, so I can see which embeddings are used, which vector store was used, in this case Elasticsearch, the system prompt that was used, and of course, most importantly, the pipelines that were run. So this is the pipeline I just ran. It's running on my computer, but being tracked here. If I click on it, I can see the code that was used, the logs, what were generated, the configuration. So there's a lot of reproducibility in this. Also, it returns data artifacts. So in this case, the URLs that were stripped. And if I go to actually a different pipeline, let's say this one, the one that successfully ran through, it also produces all these visualizations for histograms and all those things that I can later interrogate. In this case, this code ran locally and pushed to Elastic. So if I go over to Elastic here, I can see this is my index. Yeah, so this is 2,100 documents. I also set it up in a way that it refreshes this index every time a new version comes. But you can see all the things that are here that are being pushed here, like embeddings, the source file. And you can probably do this a lot better than I did. I just did it for this demo. But there's many ways to do that pretty well. And this is still running. I'm going to do one more thing. So just to make this expedient and give more time for questions. Usually what I would do is so this is my local development environment, right? If I make a change to this, I just want to be very quick. So I was just making a change, being quick and producing many different model versions. What I can do after this is I can, let's say I don't want to evaluate everything and I don't want to do all the data. So you can just take a chunk of your data, do that locally, make a pull request on GitHub, and then what you can, the way I've set it up is that a new step gets added, the evaluation step here, and this evaluation step actually runs all my data, all my test set, and this time it even runs it on SageMaker. So because ZenML works on the cloud natively, the data scientist didn't know how to write Amazon pipelines or AWS pipelines or SageMaker, doesn't need to know about that. So ZenML automatically built the image around it and pushed it to Amazon, and then it just ran those tests, and then I have the same experience as I had locally, but with the new model version. And this time it was using S3 and SageMaker. So that's something I can actually simulate locally. So if I just change my stack to the SageMaker stack, this is a stack that I've set up before. This stack is just very simple. And yeah, let's just run the same pipeline again. So you notice I haven't changed my code at all. All I've done is I've told ZenML, hey, rather than running locally, now you should run the same pipeline on Amazon. So let's see what happens now. So it's just trying to, so now it detected about SageMaker. It said, okay, I already have a Docker image that I can use, populated the pipeline, give me some links, and then it started something. And if I actually go over to Amazon, so you don't need to be familiar with SageMaker. This might well be Kubernetes, this might well be Airflow, doesn't matter. And you can see 12 seconds ago, I'm just running a pipeline. And you can see this is the same pipeline that I ran locally. Now it's running on SageMaker. By the way, this can run on Google as well. So this is the same pipeline. By just switching one tab, I could run on Google. We also have Azure. So the cool thing about this is that you're not connected or locked in, but you're sitting on top, giving your data scientists a very simple experience, and setting up this repeatable data engine flywheel that can run locally, can run on any target infrastructure in the back. And finally, this is the last thing. What you can also do is, so we have roles and permissions. So if you want, you can gate your stacks in a way that not everybody has access to, let's say, SageMaker or AWS, but only if a compliance officer comes and looks at the evaluation reports that I showed you on ZenML, they can promote the model to production. So I can go over to my model here and say, okay, so this one is now the one in production. And this would then kick off a pipeline downstream that would then deploy the latest model, and then maybe even run more evaluation checks that are gated in another part of your infrastructure. So this is just to say that you can do a lot of work around creating a data flywheel with a central governance layer, which is abstracted away from infrastructure choices because you're not coupling your business logic to all this tooling infrastructure complexity. Cool. Awesome. So this was very quick. Sorry, usually I take half an hour just for the demo, so I'm sorry if I rushed through. So this is an enterprise process for productionizing RAG applications. I would suggest go through GitHub in all of these. So go from development to staging to production. You can use Elastic to pre-process the embeddings and generate your indices. Probably makes sense to have a separate index for each stage. And yeah, always go through some sort of model control plane that promotes the model as well, not just the pipelines. Nice. I think I have 2 minutes to, yeah, 7 minutes, but we have time for questions.
Yes.
So I'll actually stop here. I'll just say, so this is a big topic. I mean, I haven't talked about a lot of things which are also relevant in enterprise RAG applications like guardrails, collecting traces, how to annotate the traces, putting them back in. Synthetic data generation is a big topic because when I created these evaluation cases, for example, I used examples and I used OpenAI to generate a lot of cases for it to test on. So that's a very interesting topic. And if you want any of this, and if you're interested in at least a bit of what I showed you, I mean, we're very happy to give you a demo. Of course, we're an open source tool. We also have the pro version, just like Elastic. In any case, if you want to check it out and give it to your data scientists or ML engineers to use, scan the QR code, book a demo. Otherwise, I'm open to questions. Thank you.